So guys, let's talk about this base 64 encoding. So this is also similar to the ASCII encoding, but with some modifications. So in ASCII encoding we have 128 characters, and we have the special symbols like uh, tab space and non-breaking space and the new line character and every other stuff. But this base 64 does not care about all those special characters. This base 64 only cares about uppercase alphabets and also lowercase alphabets and the numbers, and at last it will also care about this press and slash. So only these characters are considered into this base 64 encoding. You can see here the index starts from 0 to 63, so these are the 64 values, and the equivalent binary number is 0. So index 0 in the binary format is 0, and the character is A. So in the base 64, 0 means A. In the similar way, 1 means B, and 2 means C, 3D, and so on up to now. We have this up to 25, we have the uppercase, and from 26 we will have the lowercase alphabets, and 26A, 27B, and 28C, and so on, and up to 51 we have the all uppercase and lowercase alphabets. From 52 onwards we will have the numbers up to 61, because these are 10 numbers, and at last these press and slash are also included in base 64. So here you can see there is a column called padding is equals to. So we will look at this by seeing an example. So what this base 64 does is, if you have any paragraph to encode or a letters sequence of alphabets, then it will take 3 alphabets at a time, like 3 characters, and then they will be converted into the ASCII binary format. So let me open this ASCII table also. So if I say A, capital A, then the equivalent binary number will be derived from this decimal 65, and then in the same way we will take 3 bytes as a group, and then these each byte consists of 8 bits, right? And in these 8 bits, if we combine 3 bytes, we will get 24 bits. So 8 into 3 is 24. So in the base 64, what we are going to do is, we will take 6 bits at a time, and we will get 4 values for those 22 bits, because 24 by 6 it's 4. So for each 3 characters we will write the base 64 for 4 characters. So if this seems consuming, if it seems confusing, so I thought to write first PPT. I want to make a slide, but this Wikipedia has this good table, and also they have mentioned the example. So that's why I thought I want to directly show you these examples. So this is a paragraph or a plain text I want to convert, and man is distinguished. Let's take a look at this man, and after this base 64 encoding we get this one. Alright, first I told that in base 64 we need to take 3 characters or bytes at a time. So the first one group is man, MAN. So in capital M, in the hexadecimal representation for capital M in ASCII is 4D. So if we convert that M into the 8 bits, you will get this one. So these are the 8 bits constituting to M, and these are the 8 bits of A, and these are the 8 bits of N. So how we got these 8 bits? You can just look at this decimal, and you can convert this decimal into binary. We get these 3. So these 3 8-bit constitutes of 24 bits. 8 8 8 24 constitutes of 24 bits. And now what we are going to do is, we are going to divide this into 4 parts, because it's 2 power 6, and because 2 power 6 is 64, that's why the maximum length we can encode is 6 bits. That's why take first 6 bits, and then you need to look at this 19 in our base 64 table. So if you take a look at this 19, it's T. So write down T and take next 4 bits, next 6 bits, you get 22. Next 6 bits 5 and 46, and look at this decimal value in this base 64 table. You get this TWFU. Okay, now what if we have some insufficient characters? So we do not have any multiple of 3 bytes. What if we have only 2 bytes? So we can convert in the same way, but we will add this padding is equals to, you can see here there is a padding, and this padding is added at the end to match the particular to equal the particular number of bits. So you will add the zeros as a padding, and you can convert this one, and you get the 4 and it's C, and you will add the padding. In the same way, if there is only 1 byte, you will convert that into the 8 bits, and then you will add padding. First 6 bits consider the 19, and then we have only 2 bits remaining for of m. So what you want to do is you put the 4 zeros, because we need the 6 bits, right? Already there are 2 bits, you need to put the 4 bits, and if you put the 0 at the right, you get the 16. And after looking at the ASCII table, sorry, base64 table, you get the Q. And this one, these last 12 bits are empty, so you can put the padding. So as is equals to. So if you want, one way to remember that this is the base64 encoding is, you can normally see the is equals to at the end of the encoded string. Okay, now let me copy this. You don't need to remember all these manual encodings, you don't need to do it manually. There are online tools for this. Let's say base64. okay, base64 encode and decode. Now I want to check this decode. I want to paste it in here, and I want to decode it. So as you can see, we have got this plain text, which is this one. So this is the very simple encoding you can do, and if you play the CTF challenges, this will be the basic challenge you can get in the CTF challenges. Even though they did not ask you this directly for 10 or 15 points, they will include this encoding somewhere in the middle of some value. So you need to decode this base64 to get another value, and you can work on that value to get the plain text or some other value. So this base64 is one of the important encoding.